In this demo, I will show you how to use the Postgres operator. You can find the Postgres operator on GitHub. It's not the only Postgres operator that is available. There are multiple ones. Everyone can create an operator for Postgres or for any other database. I took this one because it's quite popular. It has some stars and also because it has a lot of functionality. So you can create, configure, manage PostgreSQL clusters. You can scale it. You can make replicas. So it's a pretty advanced operator. You can find the official documentation here, which includes getting started. I will show you step by step how to install the operator and use it. And then afterwards, you can maybe check the documentation to see what else you can do with this operator. Maybe some more advanced things. So I'm logged in to my VM and I will go to Vagrant Kubernetes Course Postgres operator. So it's a folder in my GitHub repository. Here I have a README with all the basic commands that you need to launch the operator and to start using it. First, we need to set up a storage. So this is a storage YAML file to set up a storage class with the name standard, type GP2 in the zone EU-West1A. That's where I launched my Kubernetes cluster. So I'm going to kubectl create this storage. And then we can execute a script. So I took this script from this URL. It's from the Postgres operator GitHub. It's a quick start for the Google Kubernetes engine, but you can also use it for other ones. For example, I'm going to do it with an AWS cluster. This also works. So first it tests my kubectl connection, which is working. These are the namespaces that I have. I created the cluster 9 minutes ago. And then it asks if it can be installed on my current cluster, Kubernetes New Tech Academy. I press yes, and this will then start installation. It asks me what storage to use. I will just say standard. There are some errors here. It's in the script somewhere. I'm sure that it will get resolved in one of the next revisions, but for now, there seems to be some replacements that go wrong. But don't worry, it's for example, the storage class that it wants to replace. That's why I added a standard one, because that's a replacement that doesn't work. So for now, you can only use the one that is called standard because that's what they use. But like I said, I'm sure it will be fixed in the future. Do you want to deploy the operator? Yes. And now it's going to check whether there's already something that exists. Nothing exists, so it's going to install all those objects. So you see here the custom resource definitions are now being created. Then a service account, a role binding, a secret, config map, and then the deployment for the Postgres operator. So the Postgres operator itself is a deployment that will be running and a service to reach this Postgres operator. And now we need to do a port forward to be able to use this operator. So I'll do the port forwarding in a new window. So now I'm doing port forward of the Postgres operator. So this is unique. If you do this, it will be another string. And now I have port forwarding from a local port to my Kubernetes operator pod. In order to access the PGO CLI, place it within your path from its default location. I made a script set path that does it for you. So you can just execute set path and then you just need to log in and log out. And then you should be able to use this PGO binary. So PGO client version 3.1, API version 3.1. So this only works if you have the port forwarding on, because this PGO client communicates with this Postgres operator. Let's have another look at the README. So we set up the storage, we set up the operator, we enabled port forwarding, we did PGO version to test it, and now we can create a PostgreSQL cluster. We can do PGO create cluster my cluster, which will create a Postgres instance with the name my cluster. So we have a deployment, a service, and there's some labels. Let's use kubectl to see what is running. So now the container is creating for my cluster. So you can see here, we have also the pod for the operator itself. Pod is running, my cluster is being created. This can take some time because the images need to get pulled. Once it is created, we can do pgo show cluster my cluster, and we can do show secrets true to show the secrets, so that we can then connect using PSQL. So we can use kubectl run it, so we get a terminal, remove after we execute the Postgres image, which is just an image that you can use that is available on Docker Hub. PSQL tree, well, the tree you can remove, it's just PSQL is the name of the deployment. PSQL -h my cluster, this is the host name, -u Postgres, and ask for password. There are 3 users created: the root user, a primary user, and a test user. I'll use the root user, the Postgres. So let's do kubectl run. I'll just remove this tree, it's not necessary. I put a tree there because sometimes if you quickly want to run it again, then the pod might be already in use, so then you can add 2, 3, 4, and so on. But now I haven't run it earlier, so PSQL as name of the deployment should be fine. I'm going to connect to my cluster. This is going to pull first this Postgres image because this operator is using custom images. This is the official image. And then once I'm connected, I can use this password. If you don't see a command prompt, try pressing enter. Well, if you press enter, we are just providing an empty password. So now if you see this line, this is the time to put your password, press enter, and then you're logged in. So I'm now connected to my Postgres server that you can use now in your cluster. That is called my cluster. So the my cluster host you can now use in your cluster. I'll quit from here. And until now, it's not really different than just running the Postgres server image. But the nice things that the operator supplies are the extra features that are difficult to implement yourself. For example, create a read replica. So you can just do pgo scale cluster, scale my cluster, and this will create a read replica. So now you not only have one instance of our cluster, we have 2 instances. And one instance will be synced with the other one. So we have a read replica. kubectl get pods o wide. So now we have another instance that is being spun up. So let's use watch to wait until it's running. So now it's running but not ready. But in a few seconds it will be ready. So if you now do pgo show cluster my cluster, then we now see that we have my cluster, but we also now have a replica, my cluster replica, and they are both running. So this one is the primary and this one is the secondary. So now it's possible for us when we do maintenance on our nodes, or there will be a node failure, that we create a replica on another node if we add some more advanced plan to make sure that our Postgres can survive a node failure. In the simple setup that I did, it actually created the cluster on the same node, but you can supply strategies to make sure that, for example, you have a cluster, a Kubernetes cluster that spans multiple zones, and that there will always be a replica in the other zone, so that your cluster can not only survive a node failure, but also an availability zone failure. You can also create a cluster with automatic failover. You can specify that when you create a cluster. Now what I will show you is manual failover. So this, my cluster here is my primary. So I can do pgo failover my cluster query. And it says that I can failover to this target. So now what will happen is it will create a pg task, a failover task, that will make my secondary, my replica, the primary. And then when I connect to my cluster, I will connect to this pod instead, the secondary. So let's do pgo show cluster again. And now the other one became the primary. And now what is happening is that because we did a failover, it also created this replica on another node. So now if you wanted, we could do some maintenance on this node, for example. It's still pending. It takes some time to make this one primary, but this is going to happen very soon. This task, this PG task, is also a CRD. So we can do kubectl get PG tasks, my cluster failover minus o YAML to show this YAML file. So this is a custom resource definition. It's a PG task. So if you want to see, for example, all the resource definitions, you can do kubectl get CRD, and you will see that these are the CRDs created by this operator. So this is extending the Kubernetes API, and this allows me to use this API version and this kind. So we have, for example, one for clusters, one for replicas, one for tasks. We can also upgrade our Postgres, and we also have a CRD for this. So this is all custom, and this tool is creating this for us so that we don't have to do it. But with some other operators, you have to write these custom definitions. Let's have a look again. Get pods. So now we have a running pod on a different node. So my cluster xvis is running on a different node and is now, if you do pgo show cluster, it is now the primary and it's running. So this operator provides so much more than just running yourself a Postgres server. This is a really good example that shows you that operators can be very similar to cloud services. If you want to run PostgreSQL yourself on Kubernetes, you might not want to build it yourself, but use, for example, this operator or another one to make the maintenance and the management, the scaling much easier for you. So this is a great example that you should test out. And then, like I said in the operations lecture, there are many more operators available. On the core OS website, you will find some operators, but also just on GitHub repositories, you will find operators that you can use.